Hi viewers. So in this video, I'm going to talk about Kubernetes replica sets. So what is a replica set and why we need in Kubernetes to start with? So in some of my previous videos, I have already discussed some of the basic concepts of Kubernetes, and also we looked at deployments, type of resources in Kubernetes, and so forth. So replica set is another very important resource in a Kubernetes world that helps us do replication of your pods and so forth, right? So pods, as we know, are the smallest unit in Kubernetes cluster. So as we know, Kubernetes in Kubernetes you can directly work with containers. So Kubernetes brings a level of abstractions to deal with a higher level, which is to wrap containers around something called pods, and you manage those pods. To manage those pods, you can either create it directly or with even higher level abstractions like deployments. Replica sets is another higher level abstraction you can work with to manage replication of your pods and so forth. But to say that usually you also don't directly work with replica sets to start with. So you usually work with deployments which will have control of replica sets and everything. But for the purpose of this particular video, we'll be working along replica sets, not deployments. So let's first, to start with, use kubectl create to create a pod to start with, and see why we need replica sets to start with. So let's go to our uh, command line, and let's start a pod. So for example, this Flask YAML pod scenario, which we have looked at previously, creates a pod and creates a pod with this particular detail. So let's start that. So to do that, so we can say kubectl create -f Flask YAML pod and so forth. So this should create the pod, right? And I will, for example, let me just quickly keep this side by side for us to quickly refer, um, yeah, to maybe this level, yeah, so that we can have a quick look at that, what we are trying to do as well. So let's use kubectl get pod command. Get pod. As you can see, there has been another pod running for so many days. Just let's forget about that. So this is the pod that we are interested at right now. It's been created 39 seconds ago. And what I'm going to do is I'm going to delete this pod now. Right. So let's do the kubectl delete pod, and I'm going to delete the Flask API pod. Right. So let's delete that. So pod will get deleted. So once the pod gets deleted, let's go and check for the pod again. And as you can see, you only see this other pod, and that Flask API pod is gone. And this is expected, right? So you said to delete the pod and you're gone. So, but in general, when it comes to running certain applications, sudden demise of these kind of pods is not acceptable, because in general you want these pods to keep on running to serve traffic or various other purposes. You don't want these pods to suddenly disappear for whatever reason, maybe for a node failure or an application failure and whatnot, right? You always want to make sure that a certain number of pods, for example, to keep running. So this is a very important aspect in Kubernetes replication controlling. So replica sets is a resource in Kubernetes to just to do that. in case if a pod disappears because of a node failure or an application failure, Kubernetes has means to create pods to replace that disappeared number of pods. So this is one important aspect of replica sets. So let's then see this replica set YAML file. So for which I have my Flask replica set.yaml, which is the same as what you see on the right? So if I just open it up, as you can see, you define the kind as replica set, and you have three replicas, and the match label is Flask API, so it will have the label Flask API attached to that, and this should match exactly. So this template, label of the application type should match to the match label of the replica set, the selector, how does it select, and so forth. So this is very important because this is how replica sets work, because it is how it will make sure that the containers which are under its control, or pods under its control rather, right? And then you give the relevant container and so forth. These are the details that we already have seen. So if I just open it up, the pod once again, yeah, so you can see this one. So, and also look at this API version. This says version 1, and in the replica sets it says application version 1. So in Kubernetes world, different resources are organized into various different groups or APIs, you may call it so. So some are at the root level as v1, some are at a level down, such as in apps and so forth, right? So let's create this thing now. So to create we have to just use this command kubectl create. So let's just get out of this and start creating our replica sets. Okay, so I think our replica set name is different here. So Flask, yeah, YAML or replica set, right? Replica set. Okay, so replica sets get created with that. So the name is different here. That's nothing to worry there. And then we can see the replica set by kubectl get rs. And as you can see, replica set says 3 desired because we had 3 replicas requested, and currently 3 are running and 2 is ready, and 2 is ready to run, and we should have all 3 running now, and so forth, right? 28 seconds ago. So that means everything is fine. So now we can go and check for the pods, to request the pods. As you can see now, you see 3 pods. The reason is because we asked in the replica set a resource to run 3 pods with this, right? So we have that information already mentioned there, right? Okay, so I can also, maybe we can describe this pod to start with. So to see further details, kubectl get pod, this particular pod, the details are running. So actually I wanted to describe the pod. If you describe the pod, you see further details of this pod. Fine. And I just want to find a label. So I just want this label. As you can see, app type is Flask API, as is being specified in the replica set. So whatever pod that comes up with this particular replica set will always have this label attached to it. So we are saying attach this label to this pod and so forth, right? And so now all of these pods will have that label. Okay, so now we want to delete a particular pod and see what happens, right? And now let's take the pods once again. Now all of these pods have been running for 2 minutes and 20 seconds up to now, right? Now what if I delete one of these pods? Let's select this pod, the unlucky one, kubectl, and then let's say delete pod, and then we are deleting it. And this pod gets deleted right away. Right. So when this pod gets deleted, I'm going to show you get pod. As you can see, 2 minutes and 48 seconds, 2 pods were running. And you see another pod that has immediately spawned up 8 seconds ago. This is exactly what Kubernetes replica sets are for. Now see, a one pod got disappeared and immediately another pod got created. No one told Kubernetes to start a new pod and so forth. It automatically detected this replica set. Desired state should be 3 pods running, but now I see 1 pod missing. I should start a new pod. That's exactly what happened, right? And so this is a great thing. This is what actually replica sets are for. And yeah, so and replica sets you can use as I mentioned previously, as its name implies, replica sets can be used for replication. Right now, in this case, we had 3 replicas, but if you want this to be higher, right? We can do it in various other ways. So you can use kubectl edit command. I believe my editor is configured. Let's see. If not, I think it should. Yeah, it just comes up. So you see the replications, right? So you just have to make a change in this replication replica sets to 5 and save, right? So it just brings up my VI editor by default when you say edit, which is great. So if you just live edit that and save it, the replica set is considered edited and Kubernetes will get to know about it, and then you can see get pods, and now you see 5 pods because I just said, and 2 have just been started 10 seconds ago. So this is a great thing to control, and this is exactly what Kubernetes is for. And in general, it can get more details and control more things like this in a real world deployment, which is going to be very useful. Well, so that's all. But before we just wind up, let's also do a few more things to understand a little better on the show labels thing. So because I said when you have something under the control of replica sets, it will have all those um, you know pods with this particular label app type flask API, which is what you saw here. App type label flask API, and this is my match label and the application type flask API and so forth, right? And so this is important. So what if you, let's say, add a new label, for example, changing the label of the flask app rs, one of the pods, right? Label pod app type to something else. Let's say we do that. What happens? That particular pod will fall out of the scope of the replication or replica set. So then replica set will understand a pod has disappeared. Even though the actual pod is running, we have just changed the label, it will understand it has gone out of its scope and it will try to create a new one. That other particular pod that you just will be making with a different label will still remain, but it will not be controlled within the replica sets. So let's say I'm going to use this xt4, or else let's choose one that has been running for a while, 65xh2. I'm selecting this one, and I'm going to change the app type to something different, and we need to override, otherwise you can't do that. So let's say that, and once I do this, the label has changed. Now if you will be able to see, so a new container is being immediately created, and your xh2 buggy label still remains, so it will just be there. So if I just say get pods to make it easy, you see 6 of them, and of course one of that is now this one. is not under the control of the replica set. So if I happen to delete this now, replica set won't be creating a new one because it will be gone forever. So yeah, so let's delete that and see kubectl delete pod, and I'm going to select this one, and that pod is deleted. Right, it's gone, and you won't see it coming back again in a new form, right? And then we can also delete the entire replica set, so we'll come to that. Now, you, as you expect, we have only 5 pods running, right? Now, if you want to deleting the replica set, you can delete the entire replica set. Okay, so when you do that thing, all the pods under the control of the replica set will also get deleted. So let's do that and see now. So kubectl delete replica set. My replica set name is flask app rs. So when I did do that, I can see my pods are getting terminated. See, it's in the terminating process. Still going. Yeah, it's gone now. Right? So, well, that's all I wanted to discuss today. But I just want to quickly wrap this up with one note on what is the difference between the replica set and replication controllers. So, if you have been working with Kubernetes for some time, you would have heard this other resource type named replication controllers. Actually, replication controllers existed before replica sets, and they had the same function. So then what's the difference? The difference is you can consider replica set as an evolution of the replication controllers and have a little bit better functionality than the replication controllers. So the major difference that you have is on this label selection. So in replication controller, you could just do whatever we did right now. That's possible. But in replica sets, you can do complex label matching, which was not possible with replication controllers. As such, now, even though replication controllers exist for backwards compatibility reasons and everything, you should never use replication controllers moving forward. Instead, you should try to stick with replica sets if at all you want to use that. But in practice, you should try to use even higher level abstractions like deployments for the argument's sake. And yeah, that's all that I wanted to cover today on Kubernetes replica sets. And I hope to create 2 more videos on daemon sets and jobs, which I have covered in my this blog post. But I want to create a new video for that because it covers some different concepts and so forth. So let's meet on another video very soon. Thank you for watching.